Hello, my name is Vienna Morrill, and I'm happy to present my proposal for a study that assesses the nutritional intake of plant-based triathletes training for Ironman distance events. The interest in vegetarianism, veganism, and plant-based nutrition continues to grow. At the same time, endurance events continue to grow in popularity. Perhaps one of the most prevalent examples of endurance events is the Ironman distance triathlon, which requires an athlete to swim 2.4 miles, bike 112 miles, and run 26.2 miles. As one might expect, training is rigorous, and an effective nutrition and hydration strategy are essential. Within the triathlete community, there are a growing number of professional athletes following a plant-based diet. Athletes may choose to follow a plant-based diet for potential health benefits, including improved immunocompetence, a reduction in exercise oxidative stress or inflammatory markers, or for longevity and reduced risk of heart disease, cancer, and other chronic diseases. Scholarly review acknowledges numerous benefits of plant-based diets, but also says plant-based diets are more susceptible to certain nutrient deficiencies, which can place athletes at increased risk for a number of health conditions and ultimately threatens their athletic performance. Accordingly, my research proposal addresses the question, do plant-based diets followed by triathletes training for Ironman distance events meet recommended dietary intake levels for nutrient recommendations? This question will be evaluated by examining the micronutrient and macronutrient intake of a sample population of plant-based triathletes. A key definition for this study is the term plant-based. A plant-based diet is often used synonymously with a vegan diet, which abstains from any animal-derived products, namely all meats, poultry, seafood, and dairy. A plant-based diet is a bit more specific than a vegan diet in that it focuses on consuming whole foods and abstains from refined and processed foods. This study focuses on plant-based diets to understand if these nutritionally dense eating patterns, often selected for health purposes, are effectively meeting needs. A review of the literature highlights the fact that there are studies that address vegan, vegetarian, and plant-based diets for the general population, studies that address the diets of endurance athletes, and studies that specifically look at the nutritional intake of female athletes. Just last year, David Rogerson published a review that synthesizes these areas of research, along with a couple case studies, in the Journal of the International Society of Sports Nutrition. Rogerson concluded that while there are many benefits to the plant-based diet, there are also nutrients for which athletes may be more susceptible to deficiency if not proactively managed. Rogerson's review points to the need for studies that directly assess how well plant-based athletes are meeting nutrient needs. As you can see in this graphic, there are similarities and differences in the nutrients that have been identified in the course of scholarly research as being at higher risk of deficiency in each population. This proposed study aims to evaluate the intersection of these three populations, assessing the actual dietary intake of athletes for what has been termed nutrients of interest. The study will use quantitative analysis to assess triathletes' dietary intake records for a 5-day period. This will occur during a period of intense training, falling within 2 months of the athlete's planned Ironman distance event. Food intake records will be collected using the web-based application Chronometer. Chronometer has been used in a handful of recent studies, and it's an increasingly popular choice among researchers and dietitians due to the expansive size of the underlying food database and its ability to track over 16 nutrients. The study will also include a validated exploratory questionnaire that collects demographic information, as well as additional information about the athlete's background in triathlon, training levels, and nutritional perspectives and behaviors. Athletes will primarily be recruited from event registration sites and email distribution lists. This approach is consistent with Masson et al.'s approach to the 2015 study of the dietary intake of 297 multisport athletes. At the heart of this study will be the web-based food application Chronometer. Here I provided a screenshot which shows a portion of the dashboard view of the daily nutrient intake levels. This is a nice graphical interface, but it's important to note that all the underlying data can be exported to Excel format. Of note, I've highlighted the purple circle, which indicates what percentage of all targets, this is macronutrients, micronutrients, calories, the individual has achieved each day. This is the nutrient intake score, which is a key element of our analysis. There will be two main components to the analysis portion of the study. The first will focus on the dietary intake score and how the output differs among male and female athletes. This will include statistical analysis using a chi-square test for differences. The second component will focus on descriptive statistics, summarizing population demographics and providing detailed results for all nutrients of interest identified in the literature review. For each nutrient, the analysis will include the mean result and standard deviation for male and female athletes, as shown in the sample table on the slide. Because the validity, accuracy, and reliability of chronometer is unknown, the continuous data provided by chronometer will be categorized into nominal data sets, as shown here. This is consistent with the study's objective to identify trends in data, not to provide precise calculations of overall nutrient intake levels. Key strengths and limitations are summarized on this slide. Notably, this topic is important, timely, and will contribute new information to the discussion of plant-based diets for athletes. With a growing number of athletes adopting plant-based diets, sports dietitians, trainers, coaches, they need research-supported information to help guide their clients in proper nutrition strategies. The study builds upon previous research, both in theoretical framework and methodology, taking into consideration recruitment strategies and data collection methods used successfully in the past. Standardized data collection tools reduce bias in interpretation of results, and participant communication and education will be emphasized throughout. Ultimately, it's going to provide a rich data set that can be used in future research as well. On the limitations, most notably, the validity and reliability of chronometer is unknown. There is also an internal threat to reliability in that athletes may under or over-report food intake and may make dietary adaptations to improve their scores throughout the 5-day duration of the study. Also, there is no theoretical framework on which to base expected values in the chi-squared analysis, so we need to assume a normal distribution. This study has been designed with the intent for the outcomes to support future research into the diets of plant-based athletes. Because this project will produce a rich data set with the combined data for chronometer and the data from the exploratory questionnaire, there will be opportunity to do additional correlation analysis with a variety of variables discussed in the detailed prospectus. For instance, looking at training and performance levels, nutrition behaviors, and supplement use. Finally, if nutrients of concern are validated, future research could explore different interventions for addressing those deficiencies, possibly through education, supplementation, or food fortification. This concludes the summary of my research proposal. I thank you for your time. I look forward to your feedback, and I hope that you are as excited as I am to further explore the topic of plant-based diets in athletes.